This is a presentation on the new features within Alphacam 2016 R1. This presentation will show the enhancements we've made to the soaring command. We've now added the facility to add a scratch cut in. When you're cutting laminates, if you just try to cut in one go, there's a chance that breakout could chip the laminate. We do a very shallow cut and we call this a scratch cut. When the top of the laminate has been cut through, you can then cut deeper without the worry of the breakout damaging the laminate. We also have the option now to cut internal arcs. If you have a 5-axis head type machine, then the disc can be inclined to a specified angle and it can then cut an internal arc without the actual disc fouling the parts of the arc. We also have the option to cut shapes. You can now draw a profile and the disc will then slice this profile in a series of cuts where you can specify the step over to just give you a better definition on the profile you're cutting. And we've also added the ability for support of CAN cycles. Many of the WOP-based programming systems on board machines nowadays have cycles for soaring, and we're now able, with a correctly configured post-processor, to output a suitable CAN cycle for the machine. Let's go and look at these features now within Alphacam 2016 R1. My part on screen is made up of a laminated material. I want to go and do a pre-scratch on this, so let's start by selecting a suitable tool. So I shall pick my disc tool and we'll go now to the soaring command. I'm going to do a manual Z level cut here and I'm going to select the geometries that I require. So if I go to the General tab, I'm going to cut past the open ends by 10mm. I'm going to set the angle at 0 because the head is vertical, and in this instance I'm not bothered whether the head position is left or right. If we look at the levels of cuts now, I'm going to enter my final depth in at -5. I'm going to do it in one cut, but I'm going to add a scratch cut. The number of cuts here are for the main cuts, it is not including the scratch cut. I'm going to make my scratch depth 1mm, and I can make it the same direction as the first cut, or I can make it opposite. Here we obviously see the option to add linear code or CAN cycle if this machining is suitable. The machining data I can add stock if I require, and we have the tooling data relating to the tool. So I'm happy with this. I'll click OK, and now I can add my tool path. If we now go into the solid simulation, we'll get to see our laminated material, and we'll watch the scratch cut go and just cut through the top of the laminate, and then we'll see the tool path return to cut through to the depth as required. This shows us how we have our scratch cut. The part I now have on screen consists of an internal arc, and I'm going to want to cut this using my disc tool. So let's go and select the tool and go into our soaring command. I'm going to work with auto Z levels this time, and I'm going to now select internal arcs. If we now go to the General tab, we can see this has changed the items that I have for selection. It's only going to be machining open ends, so we'll select a cut past by 10 again. Regarding the amount of tilt required on the disc, we can select automatic, which means the system will automatically detect, due to the size of the tool and the size of the feature we're cutting, the optimum angle for tilting. You can adjust this by an extra value if required, or you can pick a specified angle and type in the angle that you want to work to. I'm going to go with automatic in this instance. Regarding the levels, I'm going to obviously go to my Z level, but I'm going to go a couple of millimeters past, and let's do this in a series of cuts. I'm not going to want a scratch cut on this one, and regarding the machining data, no stock required, but I will add a lead in lead out. We'll notice a bit of a difference here as we apply the lead in lead out, that we're actually giving a 3D lead in lead out. That's because this type of tool path will be applied as a 5-axis tool path. I'm just going to enter in the values that I require here. We'll say OK to that, and then we'll pick our arc. And we can now see that we've got our machining, and if I just run a simulation on this, we can see we have the disc and it's tilted over accordingly. I'm now going to go into the solid simulation, so prior to doing that I'm just going to open up a machine configuration, just a simple one this time of a head based scenario, and we're going to now go into the simulator. Now in the simulator we can click play and watch the machining of the internal arc. So this now shows how the system can cut these arcs for us. Cuts we'd been looking at before were basically just one type of cut down the profile. Now we have a part or a feature that is actually wider than the width of the tool. So this is going to now use the command cut shape. So if we go to select a tool, our disc is 3.2 millimeters wide. If we go into sawing, we're now going to pick to cut a shape. Looking on the general tab, we can obviously decide whether we're going to be left or right. For this feature, the tool will always be vertical. And Z levels, I'm going to go with 0 stock on this now, and I'm going to cut this in one depth of cut. No scratch cut required. Machining data, now the width of cut will always be populated reference the width of the tool. I'm just going to change that value to 3. Tool data I'm happy with, so I can say OK and go and pick my feature. And what we now get is a series of cuts to cut the feature. So if we go into the solid simulation, we can now see that we have a series of stepped over cuts to cut my slot for me. It's not just limited to slots. There's no reason why I can't come in here and edit this feature. So if I go for a fillet of 5 millimeters between this feature and this feature, and then let's do something a little bit different on the other end. Let's put a chamfer. We go for a distance of 6 and 20. So we've got these features on here. The operation needs updating, but rather than update it, I'm going to edit it now because I've actually put some features on there. To get a better definition on it, I'm going to want to have a shallower step over. If I just change that to 0.5, we're going to get many more cuts, but we'll also get a better definition on the machining. Let's have a look at that in the simulation. And we can see where the cuts are being staggered on this end for the chamfer, and adjusted on this end for the radius. We're obviously not going to get a true radius, we are cutting with a sharp tool. Obviously you might be able to use saws that also have a radiused corner edge on them. But we can see how we can use the system now to give us the option to cut more than just a single slot.